Okay, so the first question is, let E be equal to -3 to 8 to be the universal set, and A from -2 to 6, D from 0 to 7, and C from -3. So this C was supposed to appear like this. It's supposed to be closed like that as a set. The first one is saying, find the following sets and display on the number line. So B complement minus C complement. For every time you're asked to deal with such questions, the first thing you think of is, am I able to simplify? So this is going to be B complement intersection C complement complement, which turns out to be B complement intersection C. And so when that is the case, then all we need now is to get B complement and then get intersection with C. So you can opt to go for the number line or to do a direct here. So now I'll use the number line so that at least I know everyone is comfortable with the number line. So the universal set is up to 8, included. Why included? This type of brackets means include. Also -3 included. And then now we bring the set B first. The set B runs from where? This is -3. The set B runs from 0 to 7. So this is B included and included. What about its complement? Because we are interested in the complement of B. So the complement of B is going to be open, because 7 is closed in B, it will be open in the complement. You do the opposite. So you go all the way up to 8. Whatever is closed in the universal or open will not change its state even when you do the complement. You leave it the way it is. And then again here we'll do the opposite, so open, but for the -3, we'll leave it the way it is. As somebody says they can't hear anything. Is it everyone who can't hear or others are able to hear? So we can know what the problem is.
I'm able to hear on my part.
Okay, so I don't think it's this. This is the issue of network. We can try to log out and log in and have an issue of network. Okay, so what we have here is B complement. Now the question is asking us to intersect B complement with what? The set C. So we need the set C. So where is C? C is from -3 to 5. But we could also write C as an interval, -3 to 5. We close because we have less or equal to, less or equal to. So we'll close or close. So now from -3, which is here, all the way up to 5. 5 is somewhere here. So we'll move, this is our C, and it's closed. Now the middle part is B, which is not useful in this case. Remember, this is B, but the question is asking for B complement, a B complement, and C. So where are these two intersecting? Where is B complement intersecting with C? So we are seeing that these are intersecting here all the way up to 0. This side, there's only B, but there's no C. There's only B complement, there's no C. So we can't call that piece a common piece. It only belongs to B complement. The intersection needs the common piece. The common piece here is from -3 all the way up to 0. With -3 included, but 0 is not included. because it's in C, but not in B complement. That point must be picked, that it's in C, but not in B complement. Therefore, it won't be in the intersection. It won't be in the intersection. Do we have any questions there?
What about that one? Because it's showing C with two complements. Then okay, yeah, okay, and I understand that one. Oh, so if there are two complements, then they cancel each other.
Yeah, they cancel each other.
Oh, okay, I understand now. I understand.
So
Yes.
I wanted to ask on the part where they're saying X is a member of real numbers where -3 is less than. Now, is it okay if you pick -4, or if you can pick -4? Because they're saying that -3 less than or equal to on the part C.
If you got -4, then you would have brought in so many numbers that are in between -4 and -3.
Oh, okay, thank you.
Yeah, so you use the same, for real numbers, you use the same numbers given as boundary. What matters is how you use them.
Okay, thank you.
Okay. So I'll use the same space to solve part 2. So if someone wants a screenshot, this is the time to do so. Okay. So we now go to B. So B is saying, part 2 is saying A intersection B intersection C complement. So we'll first find the B intersection C complement. Now we already have C complement. We talked about which one to get the complement. Oh, we got the complement for B. So now we need to get the complement for C. So let's go to the line. This is 8. This is -3. C is running from -3 all the way up to 5. This is C. Okay. What about C complement? C complement will be the opposite of this C. The part that doesn't have C but belongs to the universal set. So this part here doesn't have C. So this is all that we're going to call C complement. But how do we describe that? So that part is running from 8. It comes all the way from 5. But because 5 is in C, the complement won't have 5. It will be open. So this is C complement. Now we want to intersect that C complement with B. So we need to bring B here. So B runs from where? B runs from 0 all the way up to 7. So from 0 included all the way up to 7 included. This is B. So now where is B and C complement? Where are the two intersecting? As you can see, they are intersecting in this region. Here. So from 5 up to 7. So B, so I'll do it from here. B intersection C complement has come out to be 5 up to 7. How do we close? 7 is included, but 5 is not included because 5 is not in C complement. 7 is in both. Now we need to intersect further the solution we have found with the set A. So now we have set A, which is from -2, which is from -2 to 6. None of them included. Intersection. The answer that we have found, 5, 7. So where are these intersecting? Well, another way of picking the intersection is where you say, let's look at the numbers I have. Between -2 and +5, which one is bigger than the other? So 5 is bigger than -2, so we'll get 5. But between 6 and 7, which one is the smallest? So 6 is smaller. So pick 6 the way it appears there. And so this is the final solution. So we have found 5 to 6. And on the number line, we need the universal 8 coming from -3. And then we have from 5 to 6. None of them included. This is the solution.
Sir,
Yes.
on the C part, I wanted to ask if it's okay to say -3. I mean, yeah, -3. Sorry, -infinity, -3. Is it okay?
The universal is here from -3 to 8. So we don't have infinity.
Okay.
You use infinite when the universal is a set of real numbers.
Okay, thank you, sir.
So this is how you solve A2. Okay, so again, we remove this so we can do A3. Okay. So A3, we have A complement union B. A complement union B. So we need to get this set first. That is, let's go to the line, the universal 8, -3 here, -8. So then we have A complement. What is A? A runs from -2 to 6. Open, open. This is A. So what will be A complement? The opposite of A. So from here, closed all the way up to 8. This is A complement. Also, from here closed all the way up back. This is A complement. that. And then union B. So we need to get B. B runs from where? B runs from 0 to 7. Included. And then we are getting the union. So union, you shade the whole A complement. The whole A complement plus the whole B. So we shade also the whole B. Then now we put this together. So for the union, you put this together. Okay, so what is A union B? So A complement union B is then going to be from -3 to -2 included union, because there's a gap in between the shadings, so union 0 all the way up 8. Included. So this is A complement union B. Now, the question says, find A complement union B minus C. Minus means intersection, C complement. So now we need to get C complement. Now remember, we had C complement because we said C runs from -3 to 5. So the complement of it is going to be from where? So let's try to put it here. We'll bring it here. So C complement runs from 5 to infinity. So from 5 somewhere here. Open all the way up to 8, which is the blocking line there. So then we have this piece here. The intersection, remember one intersection? So it will be this piece. This piece is the intersection. Okay. This piece. Where is it starting from? Starting from 5. So it means that our intersection now is going to be from 5 to where? To 8. 8 included, but 5 not included, because 5 is not up there. 5 is not in C complement. This is the final solution. And then on the number line.
I have a question on how you got the 8, 0.8. 8.
So 0.8.
Yeah, from the looks of things here, you got -3, -2. But on the right hand side, you got 0.8.
So we got 0.8 because the two were joined. You can see the blue behind the thing I've shaded now. It's going all the way from 0 up 8. So union is addition. So you get whatever you see.
Okay.
Okay, so on the number line, -3, 8, and then you will show that, oh, the answer is from 5 to 8. Open, closed. So this is the solution. So when the question asks you to put the answer on the number line, please do so. You can use a number line to work out, but look how many things are already shaded and what's the solution? The solution is not everything that is shaded. So you must extract and shade separate to show that, oh, this is my solution. Okay. So go to the next question. We go to B now. If you want to do the screenshot, please do now, because we are about to wrap this. Okay. So then we got to B complement. So don't start buying this thing. This thing was for this. It's not just cookies. This. Okay. Okay. If A is a subset of B union C and all sets intersect, shade the set B minus A union C minus A. So now we need to shade. We are told that A is a subset of B union C. So if I put, if we put B to be this one and C to be this one, or in the universal, and then since A is a subset of B union C, it means that I can place A anywhere. I can put A even inside B. This is A. Then we want to shade B minus A union C minus A. So this is like B intersection A complement. B intersection A complement union C intersection A complement. So get B intersection A complement is everything in B outside A. One. And then second, C intersection A complement is everything in C outside A. Now, when there's union, whatever I've shaded is a solution. So we are done. That whole shading is a solution. That's the beauty about union. But if it was intersection in between there, we would have gone back to check where the two colors are meeting. But in this case, regardless of the color, whatever I've shaded is part of the solution. So we go to 2A. 2A is saying, expressed in simplest form, given the universal is E. Part 1, A minus B complement, given that A intersection B is empty. So first we simplify. The minus, when you put intersection, to take away the minus, that is, to take away the complement that is outside here, because now we have complement. Because every time you bring in intersection where there was minus, the right set, you put complement. Now the right set is in bracket. So the complement will be outside the bracket, where there's another complement. So the two will neutralize each other, and then we'll remain now with A intersection. Now we go inside and change the minus again to the A intersection B complement. So that complement has come in after changing the minus that was inside. Now, we are told that A intersection B is empty. So we can go on and distribute. When we distribute, we are going to have we're going to have A intersection A intersection A intersection B complex.
Sir,
Hello.
the first question they're saying A minus, then bracket. Was it supposed to be A complement, then intersection B, like when so meaning that it's going to be A intersection B complement, then the brackets. Now the complement will cast. Was it A will remain with the complement?
No, the A doesn't take any complement. The A would have gotten a complement if the complement outside the brackets was not taken away by the minus that is before the brackets, this minus. This minus has taken away that complement.
All right, sir. Thank you.
So now here we are having A intersection A, we get A, and then A intersection B complement is again A. So the answer is just A. So why are we saying A intersection B complement is A? Because we are told the intersection is empty. So they are sitting like this. This is B, this is A. So A intersection B complement is just the whole A. Because the whole A is outside B. Then the solution is A. The second one, part 2. A intersection B so A intersection B minus B. So this is the same thing as A intersection B intersection B complement. Now A intersection B, the whole A intersection B is in B. So this is empty. But if I can't see, then I can distribute. You say A intersection B complement intersection B intersection B complement. The first one remains A intersection B complement. The second one, B intersection FC complement, is empty. Now N set intersection empty is empty. Like that. A very nice question. Okay, so that's that. So after I do a screenshot, then we can remove this. Okay, so we've gone up to question 2A. Yeah, so we have quite a good number of questions. B, express this as a fraction, and then give an example of the sum of two rational numbers, which is rational. Expressed in terms of simple sums. Express that in the form, evaluate this guy. Then we have this, find the real and imaginary parts. the binary operation calculations. And then let A be that. So these are supposed to be sets. So A is a set, B is a set. Determine whether or not the set of product pairs, that guy presents a function from A to B, give results. So you can finish up, try to see what you get. Convince yourself is correct, at least because I know that the most people have challenges with the intervals. That's why I spend the time doing the intervals. But there's a hand, so we have a minute before the Zoom cuts.
I have a question. How are we supposed to solve a question like this? Let me just write it down on the screen.
Okay.
So it's that it was there on the tutorial sheet one. I don't think I understood how you solved this. It said simplify.
So it was just
So is it
taking-
that we can we like say that it's greater than or equal to 0, or
not necessarily, it's just to factor out the 3, and then you have x plus 3. Since it's in the modulus, so it's going to be 3 now can come out as a positive, when the x plus 3 will leave it inside. Then you're done.
so we should do this in questions that say simplify, we can just factor out such things.
Yes.
Okay, thank you.
So on the same question, is it okay to find the product and the sum when you are given where to find the product and sum?
No, that's too far. Just
Ah,
like
okay.
that.